So here we're going to look at linked lists, big O. So we're going to look at the big O of all of the things that we do with a linked list. So I'm going to bring up a linked list, and we're going to bring a node in from the right, that for node there. And if we were going to add that to the end, if we look at the steps that we're going to have to do in order to do this, we could just have that last item point to that node. And now that we have something pointing to it, we can say tail is equal to that pointer, like this, and then it's added into the linked list. And it doesn't matter if the linked list had 4 items, like it did here before we added this, or if it had 100 items, the number of steps would be the same, which means this is constant time to push something onto the end, which means O of 1. Now let's look at removing that item. It looks like all we're going to have to do is just do those steps in reverse. And we're going to take that off and move tail over, and we're done. But the problem with that is this. In order to have this pointer point to that 7 node, we have to set it equal to something that is pointing to the 7 node. And the only pointer that is pointing there is this one. And we can't go backwards in the linked list. So in order to get to that pointer, we have to start at the head and iterate through the entire list to finally get to this pointer and set tail equal to that pointer. And because we had to iterate through the entire list, that is an O of n. So popping something from the end of a linked list is O of n. Now let's look at doing this on the other end. Let's bring that 4 in over here. So we have to have the 4 point to that 11 node. And we do have something already pointing at the 11 node. That is head. So we set the pointer from the 4 node equal to the pointer from head. And that points the 4 at this node. Then we just set head equal to the new node. That's O of 1. How about if we take it off? Well, we need to set head equal to the 11 node. And we do have an item that is pointing at the 11, which is the 4 node. We're going to set head equal to head dot next. And we'll get into that when we get into the actual code. But that moves head over, and then we can just remove the 4. So removing from the beginning is also O of 1. Now let's look at inserting something into the middle of the array. So let's bring our 4 node up down here. And if we're going to insert this at the index of 3, we're going to insert it after this node here. That's at the index of 2, 0, 1, 2. In order to do that, we have to start at the head and iterate through the array to get to this point. Now we want the 4 to point to the same node the 23 is pointing to, right here. So we set those equal. Now the 4 is pointing to the same node as the 23. Then we have 23 point to the new node, and this is inserted. But because we had to start at the head and iterate through the list to be able to get to the point where we were going to insert it, this is O of n. Let's say if we're going to remove that same item. We would say, let's remove the item at the index of 3. We start at the head, go 0, 1, 2, 3 to be able to get there. Let's drop this out down here. We want to have the 23 point to the same node that the 4 is pointing to. So we set the 23 pointer equal to the 4 pointer. We drop this out. That is O of n, because once again we had to iterate through. Now let's look at finding an item. We could find something by its value or its index. Let's say we're going to find the number 23. You have to start at the head. Is this 23? No. That one's not 23, but that one is. And because we had to iterate through, obviously that's O of n. But what about by index? This is at the index of 2. If we're going to find something at the index of 2, once again we have to start at the head and iterate through. So Whether we are looking for something by value or looking for it by index, it is O of n. This is a difference between linked lists and arrays, because arrays, we can go to the index as an O of 1. So now I want to bring up a table. Let's get that out of the way and bring the table over. And this just shows all of these operations and how linked lists and arrays compare. All of the gray items are going to be the same. But we have a couple here that are better for arrays. Pop and looking up by index are O of 1 for arrays, but O of n for linked lists. And then we also have a couple that are better for linked lists and not as good for arrays, which is adding and removing items from the beginning, shift and unshift. It just depends what you're going to be using your data structure for. So I will include this table as a PDF, as an attachment, so you can download this if you want to be able to have this as a reference. And that is our overview of linked list, Big O.